Now, what does the spring constant depend on? It depends on the shape of the spring, its size, what is it made up of, how is it made. All the physical characteristics of the spring are going to play a role in determining the spring constant. Usually when you buy a spring, it's going to come with a value telling you how much it is, or you can actually measure it like what we are talking about here. Let's take an example here. When we suspend a mass of 2 kilograms, a spring stretches by 10 centimeters. What is the constant of the spring? Okay, so we have a vertical spring. It is sitting here at equilibrium. We hang a 2 kilogram mass. And they tell us it stretches by 10 centimeters. Now they're asking us what's the spring constant. Now the key here, the force that we have exerted to stretch it is equal to the gravitational pull of the mass. So actually on the mass we have two forces, Fg and the spring force. The spring force is given by Kx in magnitude, and the gravitational force is given by mg. Since the spring is in equilibrium here, these two forces are balanced, so I can write that Kx is equal to mg. So here, that gives us K, that's going to be mg over x, which is in this case 2.0 kilogram times 10 meters per second squared over 10 centimeters. Okay, the 10 centimeters, of course, I have to convert it to meters. That would be 0.1 meter, so that's going to be 20 newtons, that's the numerator, over 0.1 meters. So that's going to give me 200 newtons per meter. That's my spring constant. Now, how much would it stretch if we suspend a 6 kilogram mass? Now, if we suspend a 6 kilogram mass, it's going to be the same equation as we wrote here, with the K that we just found. The only difference is going to be in x and m. So we write that same equation, but in this case, we'll solve for x. So x is mg over k. In this case, m is 6 kilograms times g 10 meters per second squared, and then over k, which is 200 newtons per meter. Now this is 6 times 10, 60. 60 over 200. So that would be 0.3, I believe. Yeah, 0.3. 0.3 meters. One thing that I would like you to notice, the 0.3 meters is 3 times the 0.1 meter we had initially. And that's because we have 3 times the mass. This is the meaning of having or of saying that the amount of stretching of a spring is going to be proportional to the force. So when I triple the force by having 3 times the mass, I will get 3 times the stretching. And again, this is applicable only as long as we don't exceed the elasticity limit.